Hey students, in this video we're going to do some more anti-differentiation using a process called integration by recognition. So after watching this video, you should be able to determine the integral of a function using information about the derivative of the given function. Key things to remember: anti-differentiation is the reverse of differentiation or of deriving. Now, what you'll need to also remember is how to determine derivatives using chain, product, quotient rule. A lot of those rules will be using in any sort of example where you have to do integration by recognition. Right, now, since generally speaking, integration or anti-differentiation is harder than differentiation. The rules you have to learn to do anti-differentiation are generally much trickier than the ones you have to learn when you do deriving. So if you think about the chain rule, product rule, quotient rule, those rules we know, we've got them on our formula sheet, they're pretty easy to use and remember. To do those three rules in reverse, to use them to anti-differentiate, that's much harder. That's outside the scope of math methods in Queensland. So we have to have some other approach to integrate or anti-differentiate some more complex functions. And one approach that we can use to do that is to derive a similar function first. Then after we derive the similar function, we can then make some adjustments to work out what the integral of the function we've been given is. And this is called integration by recognition. It's probably a bit wordy to get used to. It'll be best if we just do an example. Alright, so what we have to do first is determine the derivative of e to the x squared. So if we've got our original function, so f of x is e to the x squared, and we need to work out what f dash of x is. Now looking at this one, it's not a product rule, we don't have two functions multiplied together, it's not quotient rule, it looks like it's going to be a chain rule. So for our chain rule, we have to divide our exponential as a normal exponential, so that'll just be e to the x squared. Derivatives of exponentials stay the same. And then we have to multiply by the derivative of the power. So the derivative of x squared is 2x. So that's going to be 2, simplify just to 2x e to the x squared. So there's my derivative of e to the x squared. Now, and this is the part where it's integration by recognition, is to use that result to determine the antiderivative of x e to the x squared. Okay? We have to determine the antiderivative of x e to the x squared. Alright, now what we're going to actually do first is use this definition of this derivative we've just worked out. We're going to use that first. So what we've just shown is the derivative of e to the x squared is 2x e to the 2x squared. Another way of saying that is the antiderivative of 2x e to the x squared is e to the x squared. So that's what I'm going to write here. So the antiderivative, or the integral, of 2x e to the x squared dx is going to equal e to the x squared. Right? Now, this is looking pretty good because we need to find the antiderivative of x e to the x squared. At the moment, we've got the antiderivative of 2. Where's my pen gone? We've got the antiderivative of 2x e to the x squared. So what we're going to do is basically just divide both sides, or times both sides, by half. If I times both sides by half, that 2 and 2 times half will just be 1. That left-hand side will end up being x e to the x squared dx, which is what I wanted up here. So I wrote my previous answer to the previous question in terms of an integral, and then just realized if I multiply that by half, I get the integral that I want, x e to the x squared. Now that's going to equal half times e to the x squared, so that's just half e to the x squared. And there's my solution. I should probably put a plus c on the end there. But using the information I got in part A, writing that as an integral, and then multiplying both sides by half, I got the antiderivative that I wanted, x e to the x squared, which is half e to the x squared plus c. It's a little bit tricky, but it's generally having that first step, doing some sort of derivative, and then rewriting it as an integral, and then adjusting the integral to get the integral you actually want. So we've got one here. This is one that's a bit trickier. This one was on the external exam. I think it was in 2000. Might be 2000. Anyway. So we have to determine this integral. X minus 3 over x squared minus 6x. Alright, now this one doesn't have the part A, part B aspect to it. So it involves a little bit more thought. But what I am noticing is this bit on the top looks a bit like the derivative of what's on the bottom. And what rule do I have that has the derivative in the numerator and the function on the bottom? Well, it's my natural log function. So I'm going to have a guess that my original function will look something like natural log x squared minus 6x. And then my derivative of that function is going to be, well, what's in brackets stays on the bottom. And then the derivative gets to go on top, which is 2x, the derivative of x squared, minus 6. Okay. Now, that expression looks pretty close to the one I've started with. So, I might even start off with that and rewrite this, what I've just worked out here, as an integral. So my integral of 2x minus 6 over x squared minus 6x dx is going to equal natural log x squared minus 6x plus c. Now again, it's looking pretty close, but it's not quite the same because I've only got x minus 3 in the numerator I want. I've got 2x minus 6 in the numerator. I've just determined using the natural log. So I need to think, how can I change that numerator from 2x minus 6 to x minus 3? If you said multiply both sides by half, that's exactly right. That's the same as what we did in the previous example. So if I multiply both sides by half, I get to basically multiply both parts of the numerator by half each. So 2x times half will just be 1x, minus 6 times half, half of 6 is 3, over x squared minus 6x dx, and that's going to equal half the natural log x squared minus 6x plus c. So this step was missing the part A aspect, so it involved a bit of thought, a bit of complex reasoning, more so to think, well, what could my starting function be? With a bit of thought, we could work out it was a natural log function, and then we just had to, again, just do our adjustment to make sure that our integral was correct, and was actually what we wanted. Instead of being 2x minus 6 in the numerator, we were able to multiply it by half to have x minus 3 in the numerator instead. Right, so after watching this video, you should be able to determine the integral of a function using information about the derivative of a given function. Basically, you should be able to integrate or anti-differentiate by recognition.